Hi everybody, today we're doing lesson 3 on continuous data. The last lesson was discrete data and this lesson is on continuous. All right, so a continuous quantitative variable can take any numerical value within a certain range. So we talked about quantitative variables being either discrete, which is countable, or continuous, where they could be an infinite number of possibilities, and it's usually going to be within a certain range. It's usually the result of measuring and can assume an infinite number of values. And in the last class, we used the example of the weight of your dog. Class intervals. When we measure data that is continuous, no two data values will be exactly the same. Therefore, it does not make sense to talk about the frequency of a particular value. Instead, we're going to create what we call frequency intervals, class intervals, so that we can group the data. Each interval will be of equal width, and we can then talk about the frequency of each class interval. And I'm going to show you how to define those intervals. Now, a histogram, as opposed to a bar graph, right? That's what we did in lesson 2. In lesson 3 now, we're talking about continuous data. So we're going to use a histogram to display our continuous data. It's similar to the bar graph, aka column chart, but the columns touch when we have a histogram, and the values of the edges of each column indicate the boundaries of the class intervals. So, and I have a picture here just to demonstrate. This is what we did in lesson 2 with discrete data, and now we're looking at doing histograms with continuous data. Now, this is where you really need to be paying attention right here, okay? Because we are going to learn how to construct a frequency table with intervals for continuous data. So for number 1, we're going to determine the number of classes. This number is given or it's determined by convenience, and it's usually a number between 5 and 15. In the problems that we do, I will tell you how many classes to use. Number 2, determine the class width by taking our range. The range is defined as the highest value minus the lowest value, and then you divide it by the number of classes. And we're always going to round up to the nearest whole number. So if we were to get 2.1, we would round up to 3. If we were to get, let's say, 3.0, we would round up to 4. If we were to get 2.5, we would round up to 3. So hopefully you get the idea. Number 3, begin with the lowest value, truncate to the nearest whole number, and add the width. So we're going to have an interval where x is going to be greater than or equal to the lowest value of the interval and less than the lowest value that has been truncated plus the width. Right about now, you're probably like, I have no idea what you're talking about. Don't worry, we're going to do some examples, and this is going to all come together. Number 4, the next interval will begin on the end value of the last interval. Then we add the width, repeat until all class intervals are defined. All right, so let's get right into it so that you can understand. This is really not a difficult process. Once you get the hang of it, you're going to be fine. A sample of 20 juvenile lobsters was randomly selected from a tank containing several hundred. The length of each lobster was measured in centimeters, and the results are given below. So the first thing we're going to do is organize the data using a frequency table with 5 classes. Okay, so how are we going to do that? First, we need to understand what the width is, all right? And if you notice up here, it says determine the class width by taking the range and dividing it by the number of classes. All right, well, in order to do the range, we need to know the highest value and the lowest value. And if you scan the data here, you're going to realize that 7.3 is our highest value, and 3.1 is our lowest value. And we want to find the width. So before we can start doing our frequency table for continuous data, we need to know what the width is. So that's going to be our range, right, which is high minus low, divided by the number of classes. All right, not too bad. So our range would be 7.3 minus 3.1. That would give us our range. And the number of classes is going to be given in all of our problems, and that's 5. So if we do 7.3 minus 3.1 divided by 5, we're going to get 0.84, and we always round up. We always round up. That would go to 1. So our width is a value of 1. All right, now the next step says begin with the lowest value and truncate it to a whole number. Well, our lowest value in this case is 3.1, and if we truncate that value, meaning we just cut off the decimal, we're going to get a value of 3. Right? And then we're supposed to add the width to get the end of the interval. So we start with 3, we add our width, which is 1, that gives us 4. And L is going to be greater than or equal to and less than. Then the next interval begins on the end value. So we're going to start here. We ended with 4, right? We ended with 4, so we're going to start with 4. We're going to add 1. All right, we ended with 5. We're going to add 1. We get 6. We're going to start with 6. We're going to add 1. We're going to end with 7. We ended with 7, so we start with 7. All right, and we end 7 plus 1 is 8. So we said we were going to have 5 classes, and we have 5 classes. All right, so now this again, we're going to make our frequency table, and we're going to use tallies. Takes a little bit more concentration when you do this, okay, because now we've got decimal values. Sometimes what I recommend to students is you take all the values, you put it into a list in your calculator, you sort the list, and you count that way. What I have found from my experience in recommending that is that no one does it because nobody wants to type all the values into their calculator. So I'm not going to do that. I'm going to just use my friend, the tally method, and I'm going to go with it that way. All right, so you can watch me do it if you want. Otherwise, pause the video and then restart it when you're ready. Okay, so we have a value of 3 for the first interval, 6 for the second interval, 5 for the third interval, 4 for the fourth interval, and 2 for our fifth interval. All right, we're good to go now. Now we're going to make our histogram, but keep in mind when we do that, the bars are going to touch because now we have continuous data. And we have to mark up our possible values. Our values go from 3 to 8. So we're going to start at 3 and we're going to go up to 8. And our frequency starts at 2 and the highest value is 6. So I'm just going to use, 1 through 6. All right. Do this in a different color here. All right, so for the interval from 3 to 4, we have a frequency of 3. So we're going to go from 3 to 4. From 4 to 5, we're at 6. From 5 to 6, we're at 5. From 6 to 7, we're at 4. And from 7 to 8, we're at 2. And like I've said in the past, I like to kind of shade in my bars. It makes everything stand out. And it makes me happy. All right, let's see what the problem is asking. Let's go back to our problem. It says, organize the data using a frequency with 5 classes. Done. Construct a histogram. Done. State the modal class and explain what this means. Well, our modal class can be determined by looking at the highest bar, right, in our histogram. So for letter C, the modal class, what is the mode? And that's going to be our second class interval, which is between 4 and 5. What does this mean? This means that more lobsters have lengths in this interval than any other. All right, the last question, describe the distribution of data. As you know, I like to draw a line over my data so I get a feel for it. All right, and in this case, the data is skewed on the right. So that means that our data is positively skewed right. And the question is, including when you're describing the distribution, I mean, are there outliers or not? And since all the bars are touching, we don't have anything sort of separated from our histogram. We have no outliers. All right, that is it for that problem. Okay, the next problem says a group of 25 junior athletes participated in a javelin competition. They achieved the following distances in meters. All right, so the first thing we need to do, obviously, right, is find the width. And again, the width is our range divided by our number of classes. Now, 5 is a pretty common number of classes to use, so you'll see that a lot, but it doesn't mean it has to be 5. All right, now our range is going to be our highest value minus our lowest value. And, again, you may want to put the values into a list and sort it. It could make the process easier, but I'm just going to use my eyes and scan it. And to me, I think it might be a little quicker. So our highest value, once you've scanned the data, is right here at 42.9. And our lowest value is 7.4. So we've got 42.9 minus 7.4 divided by 5. That gives us a value of 7.1, and we always round up. So our width is a value of 8. All right, now we start at our lowest value and we truncate that value. So our lowest value is 7.4. If we truncate it, we take away the decimal, we get a 7. And we're going to add the width, which is 8. So 7 plus 8 is 15. Now, what are we talking about here? We're talking about, in this case, distance in meters. So I'm just going to put a column heading here, distance right? And I'm going to use the variable d for distance. So we ended at 15, we start at 15, and we add 8. We ended at 23, we start at 23. Ended at 31, start at 31, add 8. Ended at 39, start at 39, add 8. And we're good. We said we'd have 5 classes, and we have 5 classes. So now we have to do the hard part, which is use a tally mark for every number. So what I would suggest now is to pause the video and come back and make sure we have the same thing. Okay, you should have all your tally marks. You're all set. We're just going to add them up. We have 4, we have 5, we have 8, we have 4, and we have 4. All right, now I noticed in letter D, they're asking for the percentage of athletes that threw 31 meters or further. That's going to mean I need my relative frequency. So even though it didn't ask for it in the original question, I'm just going to do another little column here to get myself ready for part D. All right, so we've organized the data using a frequency table. All right, I just want to add the total number of frequencies. 4 plus 5 plus 8 plus 4 plus 4 is 25. That'll help me when I get into, again, part D. Now I'm going to set up my histogram. My possible values go from 7 to 47. All right, so I'm going to just use the beginning and ends of all my intervals. So 7, 15, 23, 31, 39, and 47. And my possible frequencies go from 4 to 8. So I'll just do it in 2s. You don't have to do it that way. To me, that makes sense for this particular problem. All right, so the interval from 7 to 15 is 4. From 15 to 23, it's 5. From 23 to 31, it's 8. From 31 to 39, it's 4. And from 39 to 47, it's 4. And I'm going to shade. Makes me happy. Go back to the top here, construct the histogram, we're done. State the modal class. The highest bar is our modal class. All right, so for letter C, the modal class is from 23 and less than 31. For part D, the fun part, what percentage of athletes threw the javelin 31 meters or further? So we know that we need to include this interval right here and this interval. So we need to know what is 4 divided by 25 to get our relative frequency for those two rows in our table. And 4 divided by 25 is 0.16. All right, so we've got 0.16 plus 0.16 gives us 0.32, which is 32%. So the percentage of athletes that threw the javelin 31 meters or further is 32%. Okay, that's all I have for this lesson. I hope you enjoyed it. Good luck doing the practice, and thanks for watching. Have a great day, everybody.